Welcome to The Explainer. Today, we're pulling back the curtain on one of the most critical, yet kind of invisible technologies humming away inside every modern computer. We're talking about the universal superhighway that makes everything just work. I mean, really think about it. When you're in the middle of an intense gaming session, or editing a video, or even just browsing the web, right? You've got all these different parts inside your machine that are constantly talking to each other. But how? How does that conversation actually happen? How do they all coordinate without just tripping over each other? And look, we're not talking about some slow, casual chat here. This is a blistering fast, super high-stakes data exchange happening trillions of times a second. Seriously, the sheer volume and speed, it's almost impossible to wrap your head around. And it's all thanks to this one incredible standard that basically acts as the nervous system for our entire digital world.
And that standard, it's called PCI Express, or what we all call PCIe. Now, the absolute best way to understand it is to stop thinking about it as just a bunch of wires. Instead, picture a super sophisticated superhighway, one that's been meticulously designed for just one thing: moving your data as fast and as reliably as humanly possible.
All right, so to really get how this superhighway works, we first have to meet the key players who are managing all the traffic. So let's break down who's in charge.
Yeah, let's really lean into this idea. Just imagine a massive, unbelievably efficient logistics company running the whole show inside your PC. Every single piece of data is like a package, and it has to get from point A to point B, like right now, and with zero mistakes. Okay, so first up, we've got the root complex. This is the big boss, the corporate HQ. It's built right into your CPU or your motherboard's chipset, and it's the central hub that connects your processor and your memory to everything else on the whole PCIe network. All the data traffic, it either starts here or is directed by this headquarters.
Next, you've got the endpoints. And in our little analogy, these are the customers. We're talking about your powerful graphics card, your crazy fast NVMe solid-state drive, your Wi-Fi card, you name it. These are all endpoints. They're the ones either creating the data packages or they're the final destination where those packages need to go.
And rounding out our key players, we have the switch. The best way to think of this is like a regional distribution hub. It's basically a smart traffic controller, routing data between different devices without having to bother the main headquarters with every little thing. Super efficient.
Okay, so we know who's who, but how does a package of data actually make its journey from one place to another? Well, it's not just tossed onto the highway. Nope. It's a really meticulous, three-step process that's handled by different layers of the PCI protocol.
And this layered approach is actually brilliant. It makes sure that every single piece of data is packaged up correctly, protected from errors, and then physically sent on its way. So let's break down exactly what happens at each step.
So everything kicks off at the transaction layer. This is your packaging department. It takes the raw data from, let's say, your graphics card, and it wraps it up into this neat little package called a transaction layer packet, or TLP. Then it slaps a header right on it, which is basically a digital shipping label. It says exactly where it's going and what it's for. Is it a read request, a write request? You get the idea.
From there, that package heads over to the data link layer. Now, this is your quality control department. It adds a sequence number to make sure all the packets arrive in the right order, and it adds an error checking code, so if a packet gets corrupted along the way, the receiver knows instantly and just asks for it to be sent again. It's basically like built-in package tracking and insurance.
And finally, the package is ready for delivery. This is the physical layer, the fleet of trucks, and the actual highway itself. This layer takes that fully prepped digital packet and converts it into electrical signals that physically race across these tiny copper wires on your motherboard called lanes. This is literally where the digital becomes physical.
And this is where you really see how smart and scalable PCI is. See, not every device needs the same size road. A simple little network card, it might only need a single lane, what we call an X1 connection. But a total beast of a graphics card, it gets a massive 16-lane superhighway, an X16 slot, so it can send and receive a colossal amount of data all at once.
Okay, so we've got the highway system down. But how does it get faster? Well, this is where the whole concept of generations comes into play. PCIe isn't some static technology. It's constantly evolving, always pushing forward to keep up with our, let's be honest, insatiable demand for more and more data.
And the core idea here is actually pretty simple, but it's incredibly powerful. With each new generation, PCIe basically doubles the speed limit on every single one of those lanes. So an X16 slot today is just dramatically faster than the exact same size slot from just a few years ago.
And you can see the results for yourself right here. PCIe 3.0, which was the standard for years, right? It managed 8 gigatransfers, that's billion with a B, data transfers per second on each lane. Then PCIe 4.0 comes along and doubles that to 16. And PCIe 5.0 does it again to an incredible 32 gigatransfers per second. Just wow.
So what does that actually mean in real terms? Well, a modern PCIe 5.0 slot, with all 16 lanes firing, can move data back and forth at a mind-boggling rate of roughly 64 gigabytes per second. And let me be clear, that's gigabytes, not gigabits. It's a massive amount of data.
And to put that number into perspective for you, we're talking about enough bandwidth to transfer an entire 4K movie in less than a second. It's just gone just like that. That sheer raw speed is what makes modern computing feel so snappy and so instantaneous. All right, so we've covered the key players, the whole process, and the crazy speeds. But let's bring this all back home. Why should you, actually care about this invisible superhighway humming away inside your computer?
Well, because without it, pretty much all of the digital experiences we take for granted every day just wouldn't be possible. Every single leap in performance you feel, every time things just feel faster, it's enabled by this underlying technology getting better, faster, and more efficient.
You know that buttery smooth, high frame rate gaming you love? Yep, that's PCIe feeding your graphics card all the data it needs with zero bottlenecks. Those nearly instant loading times you get with an NVMe drive? Again, that's the direct, high-speed lane PCIe provides. Faster video rendering, and even powering the massive data pipelines needed for AI and machine learning, it all comes back to the incredible bandwidth of this superhighway.
And all of this leaves us with one final big thought. We've watched PCIe double its speed time and time again. So as our apps, everything from VR to real-time AI, start demanding even more data, the real question isn't if the highway will get faster. We know it will. The question is, what incredible new experiences will the next generation, PCIe 6.0 and beyond, unlock for all of us?